Here we go. Week 13. Yeah, this is introduction to networks. April 15th, week 13. We have 2 weeks left after this week. Reminders. I'll write it right down here. Communication. You gotta let me know how things are going. And we're going to work on that the last 2 weeks. Okay, how things are going with the online stuff. Yeah. So, application, presentation, session. These layers from the OSI model, right? OSI model map to just called the application layer in the TCP/IP model. But it's all of these things. You know, the user communicates, like, for example, a browser to communicate to a network. You know, they probably want to go to, if I was going to draw it over here, the internet, and they use a URL. So there's all these protocols that know how to interpret this stuff. You know, like URL, you can't type in, well, with search engines, they kind of can change it to the appropriate thing. So yeah, there's ways the software corrects this, but yet it has to be accurate, okay, before it goes to DNS to get an IP address, and then it's going to use that IP address later on in the network layer, right below the transport layer. So this is going to tie into our applications, figure out if it needs to encrypt the data, and set up a session. If it's TCP, it's going to do the three-way handshake, and it's going to make sure it has all the material before it can move back up to the browser. Let's say you're going to get a website. So, at the transport layer, it's going to figure out how it's going to transport the data. Is it going to be a unicast? Well, I shouldn't say it. Is it going to be where it's going to be verified, or is it going to be unreliable? It's just going to send the information and hope it gets there. And then below here, we'd get an IP address of the destination, for example, from, you know, DNS, going to give us that. And your machine has an IP, so that'll be the return IP. Okay? Now, we talked about in this scenario, that would be considered a client-server environment. Okay? You have a client up here, and you're going to contact a website, you know, through the internet, and there's where the server is. In a peer-to-peer environment, we just have computers contacting computers, rather than going, let's say this one goes to this server and then comes back, server client. Okay, so peer-to-peer, PC to PC. So it's important. Okay, let me use another color here. It's important that we can distinguish the difference between these two. It might not seem important right now, but it is. Going back, a couple students had some questions. They talked a little bit about this multiplexing, the idea you can take lots of traffic and funnel it into one main line and then distribute it when it gets to the other end. Okay? And I gave lots of examples. I talked about the schools in South Dakota and Sioux Falls communicating to a computer in Watertown. They all multiplexed their information going up there. And then when it came back, it sorted it out and sent it to the right people. This is done all the time. Okay. I gave the example of the brick and tile building is a hub to send traffic out to the tier 1 providers, whether probably down towards Des Moines, but maybe out of the brick and tile building it sends it towards Minneapolis too, for redundancy purposes. All right. Now, we talked about examples for UDP. One of the examples we gave was voice over IP. That traffic, we just have to send it. Now, these packets aren't big, but they can be given priority when going through a router. And we talked about a little bit about congestion and how some packets can get to go through and others would have to wait, like if you're doing FTP for a download. Okay. And I did mention, for those of you curious, a DSLAM, DSL, popular through phone lines. At the phone company, there's a DSLAM, a DSL. I think it's asynchronous multiplexing. I'd have to look that up. I'm not sure about the A. But anyway, these devices take all those phone lines and stick them on a line that goes to the internet. And it keeps track, so when it comes back from the internet, it goes back to the right phone. And this could be literally hundreds upon hundreds, like here in Mason City. Now we're using that a lot less because we're places like CLTEL and Clear Lake. They have fiber going to so many places, and slowly the phone line usage is going away. Had a long time on the first slide. I'll try to speed it up. Intro to networks. We talked a little bit about the Easter egg hunt, right? We did that Monday. And then Monday right after Easter. Okay, we did that. Monday right after Easter. So I gave a hint here. We have a couple routers, actually 3. We have some devices on them. And from work server 2, we were able to telnet into the router. Telnet would be a layer 7. It's a protocol. Some people would call it it also uses the transport layer because it has port numbers, but the actual process of telnetting from an app, right? Okay, so you came in, and then from here you were to look for clues on Easter eggs, and we're going to go over that. I gave everybody a chance to complete it. We did it Monday initially. Okay. Then we did a little work on some routers. We got in and did a little bit of discovery work on some devices. And I gave everybody a device to log into, so we did a little more practice on that. The concept here, the goal, or the concept, or the objective, maybe I'll just call it objective. They like those in education. Student learning objective, they actually call those SLOs, is to apply your knowledge of addressing using pings and looking at addresses, and then looking in devices and seeing if you can find the addresses and finding clues then inside the routers or the switches in terms of trying to determine what the clue was leading to you do. So it's you may or may not have liked it, but I thought it was a good project. And then we logged into these devices down here, and we did a little bit of review. This device got its address from DHCP, from actually this device up here. And then we looked at, inside our devices, we looked at some routes. And, we were some routers and some switches, and we had some multiple networks, and I looked at some of the routes in here and some of the routes in here to show how these networks work, how a router can determine. So you could subnet off 3 different networks down here, but the switch was pointing at 104, so what you did with those last 8 bits, right, the last subnet, you could subnet it any way you want, because the device above you, this routing part of this device, was going to send the address to 104. Okay. Yes, so this router got a device DHCP from up here, and this device, yeah, it's connected to the firewall. Yeah, a little busy there, but that's enough. Whoa. Third slide. We talked about controlling traffic, data, and traffic. We talked about control traffic. The concept here is there's traffic on the network that's not production. It's not any traffic that a user needs, but it's used to manage the network. And you're going to learn more and more about that as we move along. Okay? So, for example, when you telnet into one of the switches or one of the devices, you're on a PC and you telnet into this router, let's say, yeah, you're using port 23 to keep track of that traffic, and then when you're doing that, you know, it's actually going right through here. That's control traffic. It has to do with controlling the equipment, configuring, and all that stuff, which is different than this PC here. Actually, let me use another color here. Actually going out. This is traffic that PC is going to the internet. That's production traffic. That's data from the PC that we need to move through. But we have to do things in order to allow that to go through. We have to have routing tables in the routing part of these devices. So this device sends the back here and not over here to some other device. And how we manage those, the devices talking to each other to manage that, would be out of, you know, like control traffic, you could call it. We got talking a little bit about security, you know, in this. And so we talked about hashing, passwords and encryption, having keys for encryption, and we talked about private and public key encryption. RSA would be an example. We did a little bit of review. We talked about protocols and their port numbers. We talked just a little bit about the idea of having, you have an IP address and a port, and so you would have the source and destination. But anyway, you put those together and we have this idea of a socket to keep track of the traffic inside your device. So you can be telnetting, and then you can SSH into something, and then you can be downloading a file. You could be running HTTP on port 80 to a non-secure website. You could be going HTTPS port 443 and doing secure connection to a website, probably using something like RSA and a protocol secured socket layer, or nowadays transport secure layer. Yeah, we'll keep moving. Okay, 2 slides left. This one obviously didn't have much to talk about on here. We talked about the public key, and we talked about shared key. A public key encrypts with, you can encrypt with the public key. You got to use the private key to decrypt it. You can encrypt with the private key. Have to use the public key to decrypt it. You never give out your private key. you can distribute your public key in order to set up a secured connection between devices. And what we're going to do is we can set up secured access to these. So we'll use SSH to communicate between the devices. Okay, instead of how did we do it before? We used Telnet before, port 23. Now we'll use port 22, and it'll be secured. So if there was a man in the middle, they wouldn't be able to read the communications. All right, I guess that's it.